Hello and welcome to Tech Tribe. And today, just a quick video. One of our viewers, he asked me about real world projects, backend projects using Go, how to structure it, and I will just show an overview on how I do structure my projects in production. And I do like to use clean architecture a lot. I don't really like hexagonal and other architectures in Go because this is one great way to work with backend systems, and it works well for me. It's really great to decouple the logic into the layers that you want. I mean that there is no right or wrong, but from all the other architectures that I have used, this is my favorite one, the clean architecture. So this project is not yet on production, but the overall architecture, this is what I do in production, right? So this is what I'm showing you guys this. So yeah, let's go. And so I will have a bin that let me zoom in. I will have a bin folder, and well, this bin folder would basically just have my binary. That's just it. And I will have the CMD folder, which, well, in this case have only a REST API. However, we could have like a, I don't know, a gRPC API, or a CLI thing. Sometimes I do that, like a CLI that will do a CLI thing to, I don't know, run the migrations manually for me. Yeah, this sort of thing. You could do other things right here on the CMD folder. So inside this main package, I will have my main func for my REST API. And on this backend, I have used Echo framework, which is, I mean, I really like Echo and using it. So I mean, you can build really fast frameworks. I mean, not only the application itself is fast, but the development time is really fast because it's so easy to write great code with Echo. And yeah, I do use Fiber sometimes for my projects. However, I usually use for things that for small projects that you need to make, like and microservices, because with Fiber, yeah, you have this thing that you can handle more requests with pre-fork and so on. But yeah, you end up not using all that. One great thing is that it spawn more process in just from a single binary. But yeah, you most of the times you end up not using that, and you have to write much more code. So that's why I do prefer to write most of my backend systems using Echo, because you have to write much less code, and it's yeah, it's a little bit easier to work with. It's really great backend. So this is an overall on how will happen on my main func. In a lot of other backend systems, I will have one of other things more here. So a resource manager, which will help me get all the resources that I'm using on backend, and a graceful shutdown to use right here. But on this API, I'm not using graceful shutdown because it's not on production yet. But yeah, this is the overall architecture, right? And right here, I'm running all up migrations. And it's running all migrations from my system inside my Docker container, inside my Postgres. So yeah, I run all public migrations, and then I run all my marketplace migrations, right? So yeah, no big deal right here. It's just a logic to run migrations. This is not the focus of this video, but yeah, just to give you an overall overview on how this works. So yeah, this is the CMD folder. We are here. Let's explain about the infra folder. So infra will be things related to database stuff, right? So I have the con package. Yeah, there are things that I will be changing on logic on this project. However, this is the focus on this video is the architecture overall, but the con, I'm basically instantiating a new Postgres connection right here, which in this case is PGX pool. I do like to use PGX a lot. It makes things a lot easier to manage your Postgres connection. Yeah, it's really great. But yeah, if you want to use nothing, use nothing. However, I haven't used. I mean, if you want to use the SQL package, native package, you can do that. But I do think that PGX makes things much easier, right? So yeah, I'm right here. I'm just instantiating the Postgres pool connection, and I'm getting it, and yeah, I do instantiate right here on the init func, and yeah, so not a lot to see here. And the migrations, as you guys saw, so this is the migrations manager, which is managing the migrations from my public migrations and my marketplace migrations. And well, of course, I will be running the public migrations before the marketplace migrations. And yeah, so that's it. And I will have to my models, and which is basically the structure of what I'm getting from my database queries, right? So let's see these right here. So the accounts, I will have in write account models, and read account models, and update account. You can have only a single one if you want to. I decided to go this way, so yeah, and all the others follows the same rules. So as you can see, I'm using, this is from pg type. This is because of SQLC. The queries returns a lot of times will return based on SQLC types, which is some of them are from pg type, which, well, yeah, it's working with database, and you have to do some conversions, but yeah, it's not big deal. Once you have everything set up from your system, it will make your life so much easier to work. And yeah, I have the repository, which I will have the repository. This is a system where I have more than one schema, right? So I will have, as you saw here, I have the marketplace and the public folder. This is one schema, this is another schema, and my migrations, I have this marketplace is one schema, public is another schema. And if you see right here, this is my SQLC configuration file. So I will have the queries and the schema on separate folders. So yeah, this will be for the public SQLC queries, and this path I will have the marketplace path, right? So yeah, everything will be really decoupled. So it will be right here, the SQLC thing, and as you can see right here, the queries, and you have the schema, and yeah, there's another one right here, which is one that I'm making the logic right now, but yeah. And this is the SQLC. It's stuff to where you write the queries and you generate them. Yeah, not big deal. And the repository thing is where we call the queries made inside SQLC, right? So they will be generated right here and we call these queries inside the repository, right? So right here, let's see the accounts. How will that be? And yeah, I have the insert account repository. As you can see, I'm not doing any scan on my hand because working on a scan by scanning your roles and so on. And I mean, yeah, this is an insert, but yeah, you usually won't have any scan thing right here on the select because right here I'm calling SQLC directly, right? So this is a query that I generated on SQLC. I'm just explaining this because the guy that asked for this video, he seems that he doesn't really know much about Golang. So I will explain on a very foundational level. So if you already know this, so feel free to um, to skip if you want. But yeah, here I will have the query, and it's the select account by username, right? As I have specified right here. And once I write this query, I can do like SQLC generate, and yeah, your configuration file must be everything correct, matching the correct files, and you must have the schema correctly for the table, which you can easily generate from your the Beaver or your JetBrains stuff. Yeah, and once I do SQLC generate, it will generate the queries for me, and I will I will be able to call this query from another place on my code. So yeah, that's what's happening. And if you click right here, this will be a generated query from SQLC as it's specified right here on my path, right? It will generate right here, the out thing. So yeah, it's really great. It makes like doing errors with human errors when working with queries and scanning your rows much less. It's much less prone to errors, right? So yeah, and inserting, same thing. Yeah, you will have the query to insert right here. If you click this, you will see how the query is. If you go here and you search, you will see that the query is basically the same. So sometimes you will have to convert and do some typecasting on your query. I don't know, let's see like this, but uh, do whatever, you know, but this won't happen. But yeah, in some cases you will have to do some type casting on your query. But if once you understand how SQLC works, your life becomes much easier. I think much easier than um, with ORMs, right? And yeah, so this is the thing, and I will have a common repository which will enable me to work with this much easier. I will implement this and do the dependency injection right here, and yeah, as you can see, I'm instantiating my public repository, which I have right here, and this is a method inside the SQLC where you can instantiate the queries and you can call each query. As you can see right here, I have an interface for my service. We'll go there soon. I will show you guys where is that. But yeah, I have this struct right here which allows me to get the PG connection. And if we go back here, you can see that I'm getting the connection from parameter, and I'm passing right here as parameter, and I'm instantiating this on my structure, and basically I'm passing this around, and I'm returning this interface which implements all my services methods, all my repository methods inside my services. We'll go there in a second. So if you see right here where I'm instantiating this, just one second, I will show you. But right here, I can access. If you see here, I have this. Each method is instantiate is uh, a pointer method to my public repository on this case, and of course on marketplace I will have the same thing, but for marketplace. And inside this structure I can have access to all my methods inside my SQLC, and that I'm instantiating right here from public package inside SQLC, right? So not big deal. If you see here, it's a public package. So this is specified right here, right? So this is all related to public queries, and this is related to the marketplace schema queries, which will be right here. So this is how I'm instantiating stuff. So yeah, that guys, there is no right or wrong, but working this way, I find it's very smooth and clean to maintain things, right? It's very, very, very great to work with. And yeah, on marketplace, I will have the same thing, the same logic. As you can see, I'm instantiating all the marketplace queries right here, SQLC thing to call the queries. So yeah, no big deal. I think this is well. If you guys have any question down below, you can ask me, so no problem. I can get the public repository and the marketplace repository if I want. If I doesn't have it, I will instantiate it, but it's most likely that this will never happen because I'm instantiating all of them when my application starts. I will show you where I'm doing it. So on this service manager, as you can see, I really like working this way, guys, because I will explain in a second. So um, I will have a pointer to all my services, right, on that I have. And um, the thing is, my services are right here. So this is the service manager. As you saw, I like using this pattern of having managers for stuff. So here right here I have migrations manager, and the common is like managing like my repositories and stuff. And yeah, and on this services manager thing, I do have like a structure for all my interfaces for my account, my services. So as I have more than one schema on this project, I will have this decoupled. And yeah, right here I have the public services. So if you see right here, I have the services, which will have the methods inside my services. So if you see here, I have the create account method, right? So this is a pattern that I love using. I use this all the time. This is from Uber style guide. So if a method is missing or doesn't have the proper signature, not only from my services and from my repository, it will, the compiler won't work, right? So right here I'm checking at compile time, right? So I do have an anonymous var right here, variable right here, which have the type of my service, as we saw here, right? And I will be instantiating this as nil, as a pointer to, as a nil pointer. And what is that doing is I can check at compile time and even before compile time if anything is missing. So yeah, this is a really safe way to work with this type of pattern. So if I go right here and see like, I don't know, just doing random stuff just so you can see how it works, it won't allow me because our function signature doesn't have this it's not on the way that the Go compiler is um, uh, waiting to receive, right? But if I do that, it then allows me, even if I'm not really using the parameter, because this way I'm just always making 100% sure that I have the signature that I want on my services. And yeah, I can't really mess around on my repositories and stuff too, because as you can see right here, I'm not, it's not waiting for, I do have to pass correctly um, my thing right here. So yeah, let's just so you can see. So if I'm passing correctly here, it won't give me an error. However, inside my repository, as we saw, I'm not assigning my method correctly. So this interface is signing all the other interfaces that I have on my services, and that's not the one. So right here I have changed it for that, right? So, but to do the thing correctly, I'd have to use right here and do that, right? So this way you really guarantee like great integrity on your code. And yeah, I really like working this way. This way you don't have a lot of trouble in production. So yeah, so this is what I like doing. And what's wrong here? Uh, yeah, let's remove that. So yeah, this is how I'm working. So yeah, this is my services, and I do like to have the interfaces for my repository and for my services separated. I mean, you could call that use case, whatever. You can do whatever you want. Some people like to do this way, but I'm doing it this way. I think it's more easy. If you want to someone else to use your code, it will be more readable, right? In the near future or whatever. And yeah, this will be all the public services that I will have inside that. And will be all marketplaces services. Again, public is one schema inside my database, and marketplace is another schema. And yeah, the services manager is basically doing that. So it's basically calling all my services that I have right in all my system inside these structures. So I will have the service provider, which will be a pointer to any of these structures, these structs. And when I will be instantiating then like a new service provider, and I will show you guys in a second where I call it. I will be doing an dependency injection from all of them, right? So I will show you in a second why I'm doing this and why I think it works really great, right? So right here I'm calling the common repository to instantiate like my repository, right? So I can call public repo and marketplace repo, and this code I already showed you guys how it's working. And yeah, it's just instantiating my repositories for me, the public and the marketplace repository, and I have the connection pool inside here. And yeah, but this, I'm injecting all of them, right? And I'm passing all the repos as a parameter, right? And right here, I'm instantiating all the services. And if you see here, I have them inside my structure. So I'm instantiating all my services, and this is right here, right? So yeah, this is, I think it's a great way of working with it. You can even do dependency injection inside your your new thing in on your services too, and you can do dependency injections here. Yeah, so this is one way that I like using it, and I have a bunch of functions that call each of them, right? So again, guys, that there is no right or wrong. I do think that this is a great way of working. Of course, I'm pretty sure there are ways of improving this, but yeah, I really like working this way, and I can get my services provider, and I can get public provider, I can get my marketplace provider, and I will show you in a second why I'm doing this. Let's see. So on my main function that we saw at the beginning of this video, I'm of course running on migrations. I'm making a new Echo API, backend API, and then I'm calling my services provider. And of course, I'm instantiating my middleware too, and um, on my inside my setup route, I will show you in a second. I'm passing my default group, which is well my echo my echo group, which will points to my API thing. And I'm passing my default group, I'm passing my services provider, and I'm passing my middlewares too. And the reason that I'm doing that is I am able to instantiate all my repositories and all my services at compile time. And this is great because a lot of people like to instantiate their services and their repositories and stuff on each handler call. And this uses much more machine resources, as I have tested so many times and have done benchmarks on it. You end up using a much more resources, and your request takes much more time to instantiate and so on. So right here on my setup route, I'm basically just instantiating all my route manager. I have the auth route manager, which will allow me to do the auth logic for my handlers. I do have my admin route manager, the accounts route manager, and so on. I will have much more because yeah, I'm building the system. But this is what I'm doing on production on my other projects, right? So if we see right here, yeah, I do have this accounts route manager, and I do have a validate JWT middleware, which I'm validating the JWT middleware. I do have, and those are my route. This thing I will be refactoring later because this could be only one line, but just so you can understand, this is a middleware that will validate users based on on this thing. It will basically just verify if it's really a user based on JWT. I do have other roles on the system, but it's not the focus right here. But yeah, this is a JWT thing to validate the role of the users based on its role level. So yeah, this is one handler, this is another one, this is another one, this is another one, this is another one. And again, this could be only one line. I will be refactoring later, but whatever. This is the overall architecture, right? And this variable right here, it's really important. I will show you guys why. Because on each thing like that, I'm instantiating a new handler based on the entity that it's related to. So right here, I'm instantiating a new account handler, which is getting the services provider. And why? And the reason behind that is I can pretty much get my services right here. I can get my get account services, and if you see right here, I'm basically returning my account services, right? So I can get all these services method inside my handler. Easy as that, just by doing that, just by doing a pointer method to my account handler, which I'm instantiating on my routes right here, and I'm passing each one of them. I'm calling right here on my routes manager, right? So this is how I'm doing, and yeah, I can easily just do like that. I'm passing the body, and this is my method to my service. And if you see right here, I do have that. This is just converting to a DTO. No, it's not. No, it's not. It's converting my DTO to a model, to my database, a pointer, and I can pass to my repository method, right? So yeah, let me see if there are more things to show you guys. So yeah, this is the meter. The halter package are basically things related to more top level logics, right? So I do have my DTOs right here, the marketplace DTOs, the public DTOs. I do have my handlers right here. I do have my meters right here. I do have my routes right here, as I just showed you guys. And yeah, that's how um, a clean architecture is structured in Go. And this is my utils, which will basically have util things, and the helpers, which will be helpers functions. So yeah, I do have helpers functions for that to work with cloud converters that are basically converting stuff for me. PG type, which converts the types from SQLC and the queries to work with and to get them from. So yeah, and this is my types package, which I basically store all my types, right? And some of these types, they are database types, and yeah. So I do have the vendor to, let me close this 1 second. I do have a vendor on this project. I mean, on all my Golang projects, I do work with vendor. I think it's really great. It really makes your project much safer, because if you download any dependency, let's say like a repository code, package, an external package that you need to use, and you don't use a vendor, and what if the company or the guy that owns the repository makes the repository like private, then you will, nah, it will not be great. So if you work with the vendor, which is really easy to use, you can just do go mod tidy, go mod vendor, and it will just create a vendor for you, which will be all the packages that you are using on Go mod. It will then download right here for yourself, and you will have this thing forever inside your repository, and you will never lose the code for that specific version that you are using. And yeah, this is awesome feature that you have in Go. And this is just a make file. I do like to use a make file on all my projects, which makes automation stuff really easy. So if I do like that, it will compile the code for me, and will run the code for me, which is just this execute thing and build thing, right? So yeah, I think this is the video for today. It's a really, I don't think it's quick, but yeah, I wanted to explain stuff like really great, because the guy didn't know much about Go. And yeah, that's it. Leave it a like below, comment down below. What do you think? What would you improve on this architecture? How you are structuring your projects in Go? And see you on the next video. Bye.